Okay, this is the last section of the 11.5 lecture. Just a little reminder of what we're talking about is the derivative, and the most common notation I will use is the prime derivative f prime of x. So we went over the constant rule where the derivative of any constant is 0. So the derivative of 15 is 0, the derivative of negative 127 is 0. Any number that's added on, the derivative is 0. Then we had the power rule that said if our function looks like x to the n, then the derivative is n times x to the new power, that's 1 smaller, and this works for any number n, including fractions and negative numbers. Then we had the constant times a function if we have 4x to the 5th, and we want to do the derivative of that. The 4 has no effect on the derivative, is not affected itself by the derivative. It just multiplies the derivative, which will be 5x to the 4th. So we get 20x to the 4th. So then we're to the sum and difference rules, and they look complicated written in this formal math language. But what it says is, if your function is made from adding together other functions, you just do the derivative of each one separately, and then add those derivatives together. So if we have a polynomial that looks like 2x to the 5th minus 4x cubed plus 7x minus 15, and we want to do the derivative of f, what this says is we do the derivative of the 2x to the 5th plus the derivative of negative 4x cubed plus the derivative of 7x plus the derivative of negative 15. So we just do each piece one at a time and then add those pieces together. So the derivative of 2x to the 5th, I'm going to go in super slow-mo, is going to be 2 times the derivative of x to the 5th plus negative 4 times the derivative of x cubed plus 7 times the derivative of x plus the derivative of negative 15 sitting by itself, that's 0. So our derivatives using the power rule, 5x to the 4th, we'll be multiplying the 2. Then plus negative 4 times the derivative of x cubed is 3x squared using the power rule, plus 7. And let's just make a little box up here and talk about what is the derivative of x. Well, you can think of x as being x to the power of 1. So the derivative would be 1x to the power of 0 by the power rule. Well, that's 1. And this is going to come up so often that you just want to memorize this one. The derivative of x is 1. So let's write off our final answer is going to be 10x to the 4th minus 12x squared plus 7. That's the derivative of this function f. Okay, so let's look at this example where the instructions say use the rules of differentiation to find the equation of the tangent line to this function y equals x to the 1/2, 4 times x to the 1/2 plus 2x to the 3/2 plus 1. The when x equals 4 part, that's the last thing we do. Don't even worry about it until we get to the very last step. So this function's name is y, so we should call its derivative y prime. So I'm going to go in super slow-mo and say the derivative of a sum is the sum of the derivatives. So that's going to be 4 times the derivative of x to the 1/2 plus 2 times the derivative of x to the 3/2, and then the derivative of 1 is 0. Okay, so we have 4 times the derivative of x to the 1/2 by the power rule It's 1/2 x to the negative 1/2 plus 2 times the derivative of x to the 3/2 by the power rule is 3/2 x to the 1/2. And then plus 0. We don't need to keep writing because that doesn't do anything. So we're going to have 4 times 1/2 is 2 x to the negative 1/2 plus 2 times 3/2 is 3 x to the 1/2. Then your instructions are always going to say write your answer without negative exponents, or it will say with positive exponents only. So you need to rewrite it, last step, with positive exponents only. So this is the derivative. Well, if I want to find the slope of the tangent line, remember that the derivative can tell me that when x equals 4, y prime equals 2 over the square root of 4 plus 3 times the square root of 4, remembering that x to the 1/2 and square root of x mean the same thing. So I have 2 over the square root of 4, which is 2, plus 3 times the square root of 4, which is 2. So 1 plus 6, or 7. So this is m of the tangent line. The derivative tells you the slope of the tangent line. So now we need to go back to the function and say, I need to find the y coordinate of the point when x is 4, but I have this function here that tells me how to find the y coordinate of a point on that graph. So when x is 4, and see how important it is to label, because now I'm doing y. I'm finding the y coordinate of a point. And I'm going to get 4 times the square root of 4 plus 2 times the square root of 4 cubed plus 1. So that's going to be 4 times 2 plus 2 times 2 cubed plus 1. So 8 plus 16 plus 1 is 25. So the point 425 is on the graph of y and on the tangent line. This is the point where they touch. So to write the equation of the tangent line, we need our slope, which is 7, and our point, which is 425. And we're going to say it's y minus 25 equals 7 times x minus 4. So then to write it in slope-intercept form, this is the point-slope form, we say y minus 25 equals 7x minus 28, and add 25 to both sides, and say y equals 7x minus 3. So this is the equation of the tangent line when x is 4. Okay, so the main thing we are going to use derivatives for in business calculus is marginal analysis. So economists use the word marginal to refer to rates of change. So recall that in section 11.3 we talked about rate of change being connected to the word marginal. So the rate of change of the cost function is called marginal cost. Rate of change of revenue function called marginal revenue. Rate of change of profit called marginal profit. This rate of change is always with respect to the number of items produced. So it is always, how is that quantity changing as the number of items produced increases by 1. That's the meaning of the marginal quantity. So the marginal cost evaluated at x, which is found using the derivative, is a good approximation of the actual cost of producing the next item. So if I write C prime of 50, this is the marginal cost evaluated at 50. This is a good approximation of the actual cost of producing the next item, the 51st item. Okay, so the meaning of C prime of 50 in the world of marginal says this is a good approximation of the actual cost of producing the 51st item. So let's talk about what is the actual cost. It's going to be the cost of producing the whole pile of 51 minus the cost of producing the first 50. So that is how you find the actual cost. Sometimes finding the marginal cost is a lot easier and quicker and is a good approximation. Okay, so the marginal cost is the rate of change of cost. It's given by the derivative, and it's the approximate cost of making one more item after X items have already been made. So I'd encourage you to write out the parallel statements for revenue and profit. So the marginal revenue is the approximate revenue of making one more item. So it's one more than however many you're already making. And notice that you have a cost of making items, cost of or cost for, whereas you get revenue from. So it should be the approximate revenue from making one more item. And then marginal profit would be the approximate profit from making one more item. So I have an example here that I picked it especially to point out something about what one more might mean in different scenarios. So in this example, this profit function is giving results in dollars. But the X value is hundreds of kegs of beer. So if we're supposed to find the marginal profit, we know we need to find the derivative. And then we're going to evaluate it at different production levels. So let's first find the derivative. We know it's going to be the derivative of the 1500 plus the derivative of 30x minus the derivative of the 2x squared. Sorry, that's a derivative. Okay, and then let's go in super slow-mo still. The derivative of the 1500 is going to be 0. It's a constant being added. Plus 30 times the derivative of the x minus 2 times the derivative of the x squared. So adding 0 doesn't do anything, so we don't need to keep writing it. 30 times the derivative of x is 1, minus 2 times the derivative of x squared is 2x. So we're getting 30 minus 4x. That is the marginal profit function. Okay, then let's think about how to use this to get some information when x is different values. So in the first example, they say when the production is 700. Well, x is in hundreds of kegs, so this is saying when x is 7. So you want to figure out p prime of 7. What is happening when x is 7? So I'll have 30 minus 4 times 7. So that's 2, and it's dollars per 100 kegs. So the units of derivative are the same as units of slope. They're units of y per units of x. Whatever y is being measured with, per however x is being measured. Okay, so then interpretation, it's not asking you for that, but let me give you that part anyway. When production is increased from 700 to 800 kegs, profit will increase approximately $2. So when I'm grading this interpretation, I'm looking for all these things. I'm looking for the word increased. I'm looking from what to what. And then I'm looking for whether the profit will increase or decrease. I'm looking for the word approximately and then the correct number. So I'm looking for all those pieces. Our language is very flexible, so there's lots of different ways to write this sentence that all have the same meaning. So you're free to write a sentence that sounds good to your ear that has all these important words in it. Okay, so B, the important thing about the example B was that x is 6.5. And in this example, you would be increasing production from 650 to 750. But the one I want to do next is the 1200. Oh, and let me ask you in each of these cases whether they should increase production. Well, if their profit's going to increase, going from 700 to 800, they should definitely do that. But let's look what happens in case C, where I have 1,200 kegs of beer. So that means x equals 12. And I want p prime of 12. And that's 30 minus 4 times 12. So 30 minus 488 is negative 18. And this is still dollars per 100 kegs. So let's see if we can interpret this one. When production increases from 1,200 to 1,300 kegs, profit decreases by about $18. So that's the meaning of the marginal quantity. Never use the word marginal. You'll see on your take-home quiz it says, don't use the word marginal in your interpretive sentence. Okay? Nobody knows what marginal means. Even people who've taken this class forget what does marginal mean. So you need to express it in simple, everyday language. Okay, so I have another example here to illustrate another nuance. So in this problem, I wanted to remind you that you can find the revenue function if you're given the demand function, which is the price per each, by multiplying the price function by x. So for this example, the revenue function is going to equal x times the price function, which is 24 minus x. So P is the price in thousands of dollars. So this revenue is going to turn out in thousands of dollars because you're taking that thousands of dollars price and multiplying it by how many am I producing. So let's simplify that a little so we just have a function that we can do the derivative of. So there's our revenue function. Label, label, label everything. Because they want us to find and interpret the marginal revenue. So I should find the derivative of the revenue. So r prime of x is the derivative of 24x minus the derivative of x squared. So that's going to be 24 minus 2x. That's our derivative function. So when x is 5, we're being asked to find r prime of 5. So that's going to be 24 minus 2 times 5. So that's going to be 14. And it's going to be the units of revenue, $1,000 per x is measuring the number of violins. $1,000 per violin. These are some pretty nice violins. Okay, so then interpret is when production is increased from 5 to 6 violins, revenue increases by approximately $14,000. So we would say, yes, you should do that, right? You should increase your revenue, your production, if it's going to increase your revenue. So let's look at B, where we have r prime of 10. So I have 24 minus 20, so that's $4,000 per violin. And your sentence would say, when you increase the production from 10 to 11, your increase in revenue is only about $4,000 per violin. And then let's look at what happens with C, where x is 12. If we do r prime of 12, we get 0. So if production increases from 12 to 13 violins, revenue does not increase. So we shouldn't do that unless we want to do it for other reasons. Okay, so some tips to keep in mind when you're doing derivatives. It's almost always easier to do derivatives or any calculus with negative exponents and fraction exponents. It's usually easier to do algebra with denominators and radicals. And I'm going to demonstrate with an example that sometimes doing algebra first can make your calculus work a lot easier. So this first problem, I'm demonstrating the use of this ddx notation that just says find the derivative of what follows. So it says find the derivative of 9x to the negative 1/2 plus the derivative of 2x to the 3 halves. But we're going to want to rewrite that x to the 3 halves that's in a denominator with a negative exponent. So let's do that. So we're going to find the derivative of 9x to the negative 1/2 plus the derivative of 2x to the negative 3 halves. Okay, so that's going to be the derivative of 9 times the derivative of x to the negative 1/2 plus 2 times the derivative of x to the negative 3 halves. And now I'm going to actually do the derivatives. So I'm going to have 9 times the derivative of x to the negative 1/2, use the power rule, negative 1/2 x to the negative 3 halves, plus 2 times, use the power rule, negative 3 halves x to the negative 5 halves, then we're going to combine the 9 and the negative 1/2. Multiplying together is negative 9 halves. And then combine 2 times negative 3 halves is going to be minus 3 x to the minus 5 halves. And then you need to write your answer without negative exponents. So this would be your final answer without negative exponents. So make sure and do lots and lots of practice problems. Okay, then this next example I chose to illustrate a couple of things. One is the variable name doesn't matter. In this case, it's t. And this problem actually asks you to do more steps because it wants you to find the equation of the tangent line, not just the derivative. So one of the things I want to demonstrate is even if you can do the derivative of some of the pieces of the function right off the bat, you need to not do that. You need to rewrite the function first, then do the derivative of all the parts of it. So I want you to label carefully that first I'm going to do algebra work. I'm not doing the derivative, and I'm just rewriting this function with fraction and negative exponents. So I'm rewriting the cube root of t as t to the 1/3, and the cube root of t in the denominator as t to the negative 1/3. Then I'm going to do the derivative, so label what you're doing as the derivative. So you're going to have the derivative of negative 5t to the 1/3 plus the derivative of 6t to the negative 1/3. So that's going to be negative 5 times the derivative of t to the 1/3 plus 6 times the t to the derivative of t to the negative 1/3. So that's going to be negative 5, use the power rule, 1/3 t to the negative 2/3 plus 6 times negative 1/3 t to the negative 4/3. Okay, then combine negative 5 times 1/3 to negative 5/3 t to the negative 2/3. 6 times negative 1/3, negative 2 t to the negative 4/3. And then write your answer without negative exponents. So negative 5 over 3t to the positive 2/3 minus 2 over t to the 4/3. Okay, then the third example I want to show you is C, where I have y equals 102 minus 6x plus 17x to the 4th over x to the 6th. There's more than one way to approach this, so I'm going to show you how I would do it. I would separate it into pieces where I know the x to the 6th needs to divide the 102. I know the x to the 6th needs to divide into the 6x. And I know the x to the 6th needs to divide into the 17x to the 4th. So notice I'm still rewriting y. I'm not doing the derivative yet. I'm going to rewrite this as 102x to the negative 6 minus 6x to the negative 5 plus 17x to the negative 2 using our exponent rules that we reviewed. Now I can do the derivative. So the derivative is going to be 102 power rule negative 6x to the negative 7 minus 6 times power rule negative 5x to the negative 6 plus 17 power rule negative 2x to the negative 3. Then our last step is just going to, well, two last steps. So negative 612x to the negative 7 plus 30x to the negative 6 minus 34x to the negative 3. And then the very last step is write your answer without negative exponents. So I've included for you lots and lots and lots of practice. These all have answers available on wolframalpha.com. So wolframalpha.com. And if you want to know how to do one in particular, make sure and ask. I don't have time, and I don't think you have time to watch me make a movie of 44 problems. So just let me know which would be the most useful ones to see. And that's it for this section.